Everyone. Today we're going to start with Chapter 1. So in this chapter, we're really just focusing on the basics of chemistry. So we're just going to look at some background information. So here on the right, you can see we have something called hemoglobin. And this is what transports oxygen in our blood to different tissues. So in chemistry, we would be interested in, for instance, how hemoglobin attaches to oxygen, and then how it also delivers oxygen. So for instance, how does hemoglobin bond to different molecules like oxygen? Additionally, you'll notice there are 4 different pieces to hemoglobin. There's 2 orange pieces and 2 red pieces. And we would be interested in how those are all connected together. But also, you might notice that there's these kind of curly loops in hemoglobin. And in chemistry, we might be interested in how those loops are formed. There are also these what are called heme groups, and that's what actually attaches to oxygen. So it's kind of this greenish piece right there, and there's actually 4 of those around the structure. So if we want to define chemistry, chemistry is the study of the composition, structure, properties, and reactions of matter. And chemistry really does happen all around us every day. So we just saw the example of hemoglobin, which will interact with oxygen. But additionally, off to the right on this slide, we have a reaction between an antacid and water. Now you'll notice that when the antacid is dropped in the water, there are these bubbles that form. And that's one indication that a reaction is occurring. So later on this quarter, we'll learn about different types of reactions and how we can tell that a reaction is occurring. So the first thing that we need to define in order to talk about chemistry is matter. So matter is another word for all substances that make up our world. So on the previous slide, we saw an antacid reacting with water. And antacid tablets are matter, water is matter, the glass is matter, and the air surrounding the glass is also matter. So everything around us is matter. For instance, if you're taking notes right now, your pen or pencil is matter, your piece of paper is matter. If you're sitting at a desk or your kitchen table or in your car, that's also all matter. Now, chemicals are substances that have the same composition and properties wherever they are found. So chemicals can be found in, for instance, toothpaste. Toothpaste is a combination of many different chemicals. And there are different types of toothpaste. So for instance, some toothpastes focus on whitening your teeth. So they might have different chemicals from toothpaste that just focuses on preventing cavities. So the type of chemicals in each brand or type of toothpaste might be a little bit different, but there are some common chemicals as well. So in your textbook in Table 1.1, there are chemicals listed that are commonly found in toothpaste. Now, some of these chemical names might sound sort of scary, but they all have a purpose. So, for instance, calcium carbonate is used as an abrasive to remove plaque. And calcium carbonate is very similar to what's found in antacids as well. Sorbitol prevents loss of water and hardening of toothpaste. So without sorbitol, toothpaste would just be dry and crusty, and we wouldn't be able to use it very effectively. Sodium lauryl sulfate is used to loosen plaque. Titanium dioxide is what makes toothpaste white and opaque. This is also found in certain types of sunscreens, but more recently, a lot of companies are trying to find alternatives to titanium dioxide because it can harm aquatic life. Sodium fluorophosphate prevents the formation of cavities, and you might notice the word fluoro. That's very similar to fluoride. So the fluoride in toothpaste helps to prevent cavities. It also strengthens your teeth. And then the last one that's listed is methyl salicylate, and that's what gives toothpaste a wintergreen flavor. So I actually think it's funny when I see commercials where they say, oh, this product contains so many chemicals. You should use this product instead. Because everything contains chemicals. The word chemical is often used as a scare tactic, but for instance, water is a chemical. Oxygen is a chemical. And these are all things that we need to survive. So I just think that's kind of interesting. So always take those things with a grain of salt. All right, so let's do a learning check. We'll do these throughout the quarter, and this is just to help you, check your understanding of the content as we're moving through. And you can always pause the video and try to answer the question on your own first before I answer it. If we were in class, I would have you raise your hand or talk to each other about the question, but unfortunately in an online environment, it's difficult to do that. So feel free to pause the video, and when you restart it, we'll go over the problem together. Okay, so which of the following contains chemicals? So we have 4 different options: sunlight, fruit, milk, and breakfast cereal. So let's start with sunlight. Does that contain chemicals? No, sunlight is actually a form of energy. So sunlight does not contain chemicals. What about fruit? Does fruit contain chemicals? Yes, so fruit has, for instance, maybe citric acid in it, maybe some vitamins. So fruit is definitely something that contains chemicals. It's also a type of matter, so matter does contain chemicals. What about milk? Yes, milk does contain chemicals. And what about breakfast cereal? Yes, breakfast cereal does contain chemicals. It has sugar, carbohydrates, etc. All right, and then here's the solution slide if you want to look at that later. So if you're studying later on, you can always come back to these questions. And next, we're going to talk about the scientific method, or how to think like a scientist. So down below, you can see a picture of Linus Pauling, and he won the Nobel Prize in Chemistry in 1954. So he actually won this prize for studying how chemicals bond. So how do things actually stick together? And the way that he came up with his hypothesis or his analysis was by using the scientific method. So let's step through the scientific method. So this is a set of general principles that helps to describe how a scientist thinks. So first, a scientist would make observations about nature and ask questions about what they observe. Now, when an observation always seems to be true, then it can be stated as a law that predicts that behavior and is often measurable. So, for instance, maybe you observe that bees like certain flowers. And maybe you make some more observations and find that bees are always attracted to the same type of flowers. So you could then make a law about that behavior. Now, next, you can propose a hypothesis, which gives a possible explanation of your observations or a law. So maybe the next step would be, okay, bees are always attracted to, let's say, wildflowers. And maybe you study wildflowers for a bit to try to determine what makes them different from other flowers. And then you could come up with a hypothesis. So bees are attracted to wildflowers for reasons X and Y. Next, you can perform experiments in order to find a relationship between your hypothesis and your observations. And then finally, after you've performed enough experiments, you can make a conclusion as to whether your hypothesis is true or false. So let's say that you do some more experiments and you find, wait, my hypothesis doesn't quite make sense. I want to revise it and maybe run some more experiments. So as another example, suppose you visit a friend in her home and soon after you arrive, you begin to sneeze. So you observe that your friend has a new cat. And you ask yourself why you are sneezing, and you form a hypothesis that you are allergic to cats. So then you perform some experiments to test your hypothesis. So maybe you go to other houses with cats, and maybe you also visit some houses without cats. So if you sneeze after leaving the other homes with cats, you can come to the conclusion that your hypothesis is correct. You are allergic to cats. Now, when you use the scientific method, you don't always have to go through the 4 steps in order. So for instance, let's say you make some observations, and if you find that they are always true, you can make a scientific law, which is just a statement about your observations. But you can also form a hypothesis. So we're just following the arrow here. And then you can run experiments to test your hypothesis. And if your experiments do not support your hypothesis, you can always go back to that step and reframe your hypothesis or make up a new one. Then, once you've performed enough experiments that do support your hypothesis, you can come up with a conclusion or a theory. All right, so let's do a quick learning check. Let's identify each of the following as an observation, a hypothesis, an experiment, or a conclusion. And again, you can pause the video if you want to do this on your own first. All right, so let's start with A. During your visit to the gym, your trainer records that you ran for 25 minutes on the treadmill. Is this an observation, a hypothesis, an experiment, or a conclusion? All right, so the trainer is just recording that you ran for 25 minutes. So this isn't a hypothesis because the trainer isn't trying to come up with a reason why you ran for 25 minutes. It's not really an experiment. You're not testing anything. And it's not a conclusion because we haven't made a hypothesis. So this would be an observation. All right, now B, scientific studies show that exercising lowers blood pressure. So is this an observation, a hypothesis, an experiment, or a conclusion? Okay, so for this one, it's not really an observation because it's something that's been studied. So that tells us that a hypothesis was formed and experiments were formed. So that word studies really indicates that this would be a conclusion because this has already been or gone through the scientific method. So these scientists already made observations, they already formed a hypothesis, and they conducted experiments that all showed that exercising lowers blood pressure. So it would be a conclusion. All right, C, your doctor thinks that your weight loss is due to increased exercise. So is this an observation, a hypothesis, an experiment, or a conclusion? So in this statement, it says that the doctor thinks that your weight loss is due to increased exercise. So you haven't performed any experiments here, and this isn't a conclusion because the doctor's just thinking. So this would be a hypothesis. So the doctor probably observed that you lost some weight and then formed a hypothesis that you lost the weight due to increased exercise. And during this quarantine, I could definitely exercise more. I don't know about you guys, but I have not lost weight during the quarantine. All right, so here's the answer slide if you need that later. Now, normally in class, we would do activities together. So I wanted to keep this in the lecture slides so you could do this on your own. But normally here we would stop and work on the scientific method worksheet. So you can find this under modules on the Canvas website, and it's listed under week 1. So feel free to work through that scientific method worksheet on your own. And then I'll also post the key to the worksheet. And then I'll also post a short video on how we came to those answers. So feel free to make some friends in the class as well, and you could maybe set up some Zoom meetings and work on this together, or it could be a Skype call, or you could even just message each other. But if you do have any questions, you can always email me or set up an office hour through the Calendly website. And the link to the Calendly website is on the main page of the Canvas website. All right, so we'll stop here today, and in the next lecture, we'll continue with Chapter 1. So I will see you then.